Let's reuse the equation from the sample problem we just looked at. So let's say quantity demanded is 10 minus 2p. Now we're going to graph this and we're going to relate the idea of price elasticity of demand and the firms deciding whether to increase or decrease their price. So before we can get started on the revenue side and the plotting of this line, we have to solve this equation in terms of price. So rearranging the values, we get that the price is equal to 5 minus 0.5 quantity demanded. Okay, let's draw our axes. We have price, we have quantity. What do we need? We need our y-intercept, and the y-intercept is basically what we get when we set quantity demanded equal to 0 here, and therefore we find that the y-intercept is equal to 5. We know this is a downward sloping line. Let's also find the x-intercept, and to get the x-intercept we would set the price equal to 0 and solve this equation, and then we'd find that quantity demanded is equal to 10. And let's connect our line. Now, let's relate this to total revenue. Okay, so how does elasticity relate to total revenue? So I'm going to plot out the total revenue here right below our demand curve. Now let's assess. So remember, total revenue is price times quantity demanded or quantity sold. So if price is equal to 5 units, right, notice that the quantity demanded is 0, and therefore the total revenue at 5 units is equal to 0. When the price is equal to 0, the quantity demanded is 10 units, but again, that generates a revenue equal to 0 as well. So we have our 2 0 points. Now, let's find a few other parts. So in the other question, we looked at what happens when the price was equal to $2, for example. So let's start there. So $2. At $2, when we plug it into that equation, price is $2. And when we plug that into our equation, right up here, we get that the quantity demanded is equal to 6. Now, what does that give us? Well, it gives us a total revenue, which is 2 times 6, or $12 in total revenue, okay? Now, what about if the price was $4, for example? What's our total revenue in that case? So at $4, when we plug that into our demand equation, when the price is 4, the quantity demanded is equal to 2. So what is the total revenue at that point? So total revenue at $4 is, okay, so once again, here's our total revenue of 8 units. Here's our total revenue of 12. Now notice that the peak of total revenue is here. And what we need to figure out is what price can we set to maximize our total revenue. Okay, so that's going to be somewhere at this point. So let's figure that out. Well, let's dot a line up here. Okay, and in fact, the point of equilibrium where we maximize our total revenue is actually found by taking the midpoint of our demand curve here. And basically, we just find the middle of the y-axis and the middle of the x-axis to basically tell us what this intercept is. In this case, it's fairly simple, right? Halfway between 0 and 5 is 2.5. Halfway between 0 and 10 is 5. So basically, at this point, if we take the price times the quantity demanded, we get 12.5 as our total revenue. And in this case, this 12.5 would go here and maximize our total revenue. Now, what does this mean? Well, it means that this portion of our demand curve is the inelastic portion. This portion is the elastic portion. And in fact, this midpoint is the unit elastic portion of the demand curve. So if we're interested in finding out what prices to charge, there's a simple formulation. And the simple formulation is if you are in the elastic portion of the demand curve, okay, what you should do, so if you're in the elastic portion, you're in this part here, which corresponds to this section of the total revenue curve. In order to increase revenue, right, we actually have to reduce the price. So as price comes down, total revenue goes up. So in the elastic portion, we will reduce the price in order to increase the total revenue. Now, if we're in the inelastic portion, so in this side of our distribution, the lower part of the demand curve, right, notice what's happening here. If we continue to reduce prices along this line, what's going to happen is as you pass the midpoint or the unit elastic point, is total revenue will start to fall. So if we are in the inelastic portion of the demand curve, then in order to increase your total revenue, you're going to have to increase prices. So to increase total revenue, in this case, we will have to increase the price. And why does that happen? Well, in the inelastic portion, consumers are less sensitive to the price change, and therefore they don't react as much in terms of reducing their quantity demanded. And in the elastic portion, consumers are very responsive and therefore will respond a lot when the price changes, so reducing the price will induce them to buy more units.